Hello students, in this lecture we will study that whether a pair of linear equations or system of equations represent intersecting line, parallel lines, overlapping lines without drawing the graph. But how without drawing the graph? By comparing the coefficients. So what is the relation between the coefficients of these variables and constant term when a system of equation have consistent or inconsistent solution, or they were intersecting, parallel or overlapping line? So first we see it, what is how we denote the coefficients. So we are considering two standard form of linear equation in two variable. Let the first equation be a1x plus b1y plus c1 is equal to 0. In first equation, the coefficient of x we will denote by a1, coefficient of y we will denote by b1, and constant by c1. Keep in your mind, in a standard form, constant we are keeping in LHS, that if it is in RHS, shift in LHS and then compare. In the same way, in second equation, the coefficient of x by a2, the coefficient of y by v2, and constant by c2. After finding these constant value, that is of coefficients of variable and constant, give their name and then substitute in this ratios, that is a1 upon a2, b1 upon b2 and c1 upon c2. You will calculate and then compare. If a1 upon a2 is not equal to b1 upon b2, in this case the pair of linear equation is consistent. If these first two ratios, a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2, in this case the pair of linear equation is inconsistent. Here we can also say not equal to a1 upon a2 is not equal to b1 upon b2. It represents intersecting line, unique solution. After reading this, we will see one table, in with that it will be more clear. If all are equal, in this case the pair of linear equation is dependent and consistent. We are considering three cases. In first case, the pair of lines are these. In second case, the pair of lines are these two. In third case, the pair of line is these two. We are finding the value of a1 upon a2. What is a1 upon a2? Coefficients of x. In first equation it is a1, in second equation it is a2. How to find out coefficients? In lower classes already you have seen it. One more time I am explaining you. In the first equation, hide that variable. What is in front of it? No number you are seeing, then it is 1. Here in second equation you want coefficient of x, hide x. What is in front of it? 3. So this 3 is the coefficient, that is it is equal to a2. So a1 is 1, a2 is 3. So what we are getting, a1 upon a2, 1 upon 3. b1 upon b2 in the same way, minus 2 upon 4. So what we are getting, minus 2 upon 4. You can write afterwards in a simplest form, that is minus 1 upon 2. What you are observing, a1 upon a2 is not equal to b1 upon b2. As we compare the ratios, so a1 upon a2 is not equal to b1 upon b2. Graphical representation. In question, whatever they are asking, according to that we will write the answer. So in graphical representation we will get intersecting line. And which type of solution? So exactly one solution or unique solution. You can also say these lines have which type of solution? Consistent. What is the meaning of consistent? When solution exists, we are saying consistent. In next equation, again we will compare a1 upon a2, 2 by 4, b1 upon b2, 3 by 6, c1 upon c2. So we are getting all are equal, change into simplest form, lowest form, then compare. So which type of graphical representation? Overlapping line or coincident line. And which type of solution? Infinitely many solution. And such type of solution is known as consistent. Which type of solution it is known as? Consistent. Third case, a1 upon a2, 1 upon 2, b1 upon b2, 2 upon 4, c1 upon c2, minus 4 upon 14. When you will simplify, you are getting 1 upon 2 is equal to 1 upon 2, that is a1 upon a2 is equal to b1 upon b2. but not equal to C1 upon C2. In this case, we will say lines have which type? Graphical representation, parallel lines, and parallel lines no common point is there, so there is a no common value which satisfy both the equation, and we will write no solution. In this case is known as inconsistent. What it is known as? Inconsistent. You can draw the graph of all these, and already in book in example it is given. With that you can also observe the exercise 3.2 is based on this concept. Now we will begin exercise 3.2. Before that you have to learn very well this formulae, that under which condition you will get an intersecting line. So a1 upon a2 is not equal to b1 upon v2, which is the condition of unique solution. So by heart you have to learn this, and then you start solving exercise 3.2. Now I am explaining you the question of exercise 3.2. First we are doing question number 2, because just now I have explained all the concepts. So with that, once again we will revise on comparing the ratios a1 upon a2, b1 upon b2, c1 upon c2. Find out whether the lines represent the following pairs of linear equation intersect at point, are parallel or coincident. In place of coincident, they can also give the word overlapping. So first case we are considering, which is the two equation, 5x minus 4y plus 8 is equal to 0. Second, 7x plus 6y minus 9 is equal to 0. Step first, check it is in standard form or not. That is, all constant are in LHS or not. If it is not, shift that. Already it is given in standard form. Now calculate a1 upon a2. a1 is what? Coefficient of x. So what is coefficient of x? 5. What is coefficient of x is next equation? 7. So a1 upon a2 is 5 by 7. b1 upon b2 minus 4 by 6, c1 upon c2 8 by minus 9. As you are simplifying b1 upon b2, first we will compare first two. If these are equal, then we will compare with the third ratio c1 upon c2. What we are observing, a1 upon a2 is not equal to b1 upon b2, as 5 by 7 is not equal to minus 4 by 6. Therefore pair of lines represent by given equation are intersecting line, and they have exactly one solution. They ask about intersecting. If you want, you can write also they have a unique solution, one solution, consistent solution, but this word has to be included what they have asked. Second case, again find a1 upon a2, so 9 upon 18, b1 upon b2, 3 upon 6. Already I have explained just now how to find out. c1 upon c2, that is the ratio of constant, 12 upon 24, so 1 upon 2. What you are observing when you are changing into simplest form, 9 by 18, 1 by 2, 1 by 2, 1 by 2, all are equal. So a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So pair of equations represent coincident lines and having infinitely many solutions. In third case, what we are getting, a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. So it represents parallel lines and having no solution. Question third is also based on the same concept. In place of intersecting, unique, parallel, overlapping, they have given the word consistent or inconsistent. Consistent means solution exists. So which two cases will come? Intersecting lines and overlapping lines. Inconsistent when there is a no solution, that is parallel lines. So inconsistent cases, a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. This is the case of inconsistent. The other two cases are of which where solution is exists, intersecting line, overlapping line, unique solution, infinitely many solutions. So these two cases are of which consistent. So in the same way, you have to compare the ratios, but be careful in question number third part, because when coefficient are rational number, in that children are doing mistake. You can also change into integers. How? By taking the LCM of 2 and 3. What is the LCM? 6. Multiply in whole equation. As we multiply in any equation by any number, equality remains same. It represents the same conditions, same situations, same equation and same result. So in the same way, now as you will do the practice, you will be more and more perfect. Next question number 4. Here some extra steps are given. Which of the following pairs of linear equations are consistent? Inconsistent? If consistent, obtain solution graphically. In previous question I have explained what is the meaning of consistent. unique solution or infinitely many solution, or intersecting lines or parallel lines. If solution exists that is consistent, then you have to draw the graph. So first part, all of you see it, x plus y is equal to 5, 2x plus 2y is equal to 10. Compare and find this a1 a2 b1 b2 c1 c2, then compare their ratios. So what you are getting, a1 upon a2 1 by 2, b1 upon b2 1 by 2, c1 upon c2 1 by 2. Compare it, what you are getting, all are equal. Since all are equal, therefore system of equation is consistent and the graph represent coincidence line. What they ask in question, if consistent, obtain the solution graphically. Now we have to draw the graph. So for first equation, already in first exercise I had explained in 9th class, you did so many questions based on this concept. Now you can easily do it. Table for equation first, at least 3 values you have to take it. In first exercise I said, as you are taking x and y value 0 to draw the graph, it become easy, so choice is yours. In second equation again, then plot it. Which type of lines you are getting? Overlapping lines. Write the scale always when you draw the graph. Its second part, again we will compare the ratio, pair of equation is inconsistent, so no need to draw the graph. In its third part, again compare the ratio, pair of equation is consistent, so when consistent, so you have to draw the graph. Which type of line you are getting? Unique solution, so intersecting line you will get it, and this point of intersection is solution. What is our solution of this system of equation? X is 2 and y is 2, and our question is complete. Next question, when one linear equation in two variable is given, how to find out one more equation such that the relationship with the given equation have intersecting line, parallel lines and coincident lines. Well, if you see question number 6, given the linear equation 2x plus 3y minus 8 is equal to 0, write another linear equation in two variable. All are knowing general form of linear equation in two variable, what it is, ax plus by is equal to c. But you have to select such equation which satisfy this relationship, that they were intersecting line this line, and what example or answer you will write it with that relationship is intersecting lines. In second part, parallel line. Third part, coincident lines. There are so many infinite examples are possible, but how to give it by yourself also you can plan it, but what I feel it easy according to that I am explaining you. So first case I am considering given equation is 2x plus 3y minus 8 is equal to 0. For intersecting line, what is the condition? a1 upon a2 is not equal to b1 upon b2. So when I have to find out intersecting line, what I am doing it, the general form is ax plus by plus is equal to c. We have to substitute the value of a and b. So what I will do it, in place of a I put the substitute the coefficient of y, in place of b I will substitute the coefficient of x, that is here 3x plus 2y, and c any value you can take it. If you want you can write 8 as it is. So here all of you see 2x plus 3x plus 2y is equal to 8. Compare it 2 upon 3, 3 upon 2, so a1 upon a2 is not equal to b1 upon b2. We do not think about c1 upon c2, because as first two cases are satisfied, not equal, then system of equations have which type of solutions? Consistent solution. Which type of graphical representation? Intersecting lines. So many example you can give it. It is not in this way you have to do it. You can take some other value. I have taken 5x plus 7y. All of you see 2 upon 5, 3 upon 7. 2 upon 5 is not equal to 3 upon 7. So which type of lines? Intersecting lines. Our first part is complete. Now next part, all of you see it. Which type of lines we want? Parallel lines. For parallel lines, 2x plus 3y is equal to 7. What I have done it, I have kept it these two same, first two terms 2x plus 3y, because for parallel lines what we want, a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. So for parallel lines, 2x plus 3y I am keeping as it is, and here you will take such a value that a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. Our second part is complete. For coincident line, concept is very easy. Whatever is the equation, you multiply whole equation by any scalar. Take any number. I am taking 3. multiply in this whole equations. When you are multiplying any number in any equation, you have to multiply in each term. So by 3 I am multiplying. So here I will get it 3 into 2, 6x plus 9y minus 24 is equal to 0. As you will find out the ratio a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. We'll get it in proportion. You can take some other number. By 10 you can multiply. So you will get it 20x plus 30y minus 80 is equal to 0, and then find the ratio. So which type of representation you will get it? Coincident lines. So our question is complete. Exercise 3.2, question number first. Form the pair of linear equation in the following problems and find their solution graphically. So first we have to represent algebraically, then we have to draw the graph, and we have to find out the solutions. Whenever any word problem is given, first step is to assume the variables. Which are the variable? 10 students of class 10th took part in mathematics quiz. If the number of girls is 4 more than the number of boys, so they are discussing with the number of girls and number of boys. So which are the variables? Let the number of girls be x and number of boys be y. According to question, first condition, total student is 10, so that is number of girls and boys is equal to 10. Second condition, they have given that if the number of girls is 4 more than the number of boys, that is girls is more. So here we assume girls is x, so x is equal to y plus 4. That is girls is 4 more than boys. So we will change this equation in standard form, then graphical method in first exercise, in first lecture. Already I have explained, so go through with that lecture and solve it in the same way. Represent on graph, but in first exercise we were not writing the answer. Here you have to write the answer where the lines are intersecting, the coordinates of point of intersection, the value of x and y. You have to write it, and this is your solution. This is your final answer. Next question, cost. They discuss about the amount, and they bought pencil and pen. So we have to assume let the cost of one pencil be rupees x and cost of one pen be rupees y. So the cost of 5 pencil and 5 pen is how much? 5 pencil and 7 pen, what they have given? 50. So from the equation, to solve it we require 2 equations. So one more condition is given, that is the cost of 7 pencil and 5 pen. So 7x plus 5y is equal to 46. Here so many values they have taken it. It's your choice. We have to go do the questions fast, so at least 3 values here to take it, and as you are taking x and y 0, calculation become easy and fast. So plan it, then plot the graph, and where these lines intersect each other, find the value of coordinates of point of intersection, and this value of x and y is the solution of the system of equation. Our question is complete. Thank you.